Hello, I welcome you once again to this tutorial. Okay, now this is another question on alpha particles and alpha radioactivity. Okay, so we are still dealing with polonium. Okay, so here we have the element polonium. This is the symbol for polonium. Okay, alpha particles having kinetic energy of 5.3 mega electron volts, okay, are subjected to a magnetic field of 1 Tesla. Now, what is the radius of curvature of their tracks? Okay, radius of curvature of their tracks. Now, the charge on the alpha particles is 3.2 times 10 raised to the power of negative 19 coulombs. Now, the solution, okay, to this problem would be, now let's first identify the given values. Now we are given the kinetic energy of the alpha particle. Okay, we have kinetic energy of alpha particle. So the kinetic energy of alpha particles is what we are given as 5.3 mega electron volts. Okay, now they are subjected to a magnetic field. So we are given magnetic field. Okay, magnetic field intensity. Okay, so the magnetic field intensity or the magnetic flux density is given to be 1 Tesla. Okay, what is the radius of curvature of their tracks? That means that the electronic charge, okay, that's the charge on alpha particle, okay, is moving in a circle, okay, along its track. Okay, so that means the radius of curvature, okay, or the radius of the moving charge describing the circle is what we call the radius of curvature. So we're also giving the charge on the alpha particle. So we have charge on alpha particles, that is given to be 3.2 times 10 raised to the power of minus 19 coulombs. All right, so we want to calculate the radius of, so we want to what? We want to calculate the radius of curvature, okay? Radius of curvature, okay? Radius of curvature. So let's represent that with what? Small letter r. Okay, so we have the radius of curvature is what we are looking for. Now we are given the kinetic energy of the alpha particles to be 5.3 mega electron volts. So we know that 1 mega electron volts is equals to 1.602 multiplied by 10 raised to the power of what? Negative 13 joules per mega electron volt. All right, so in this case, so we want to convert the kinetic energy to joules. So we then have 5.3 mega electron volts multiplied by 1.602 times 10 raised to the power of what? Negative 13 joules per mega electron volt. So mega electron volts, they cancel out, okay? So that we're going to have, so now let's get the value for what is 5.3 multiplied by 1.602, okay? That would be 8.49. So we have 8.491, then multiply by 10 raised to the power of minus 13 joules. Okay, so this is the kinetic energy. Okay, this is the kinetic energy in joules. All right, so to be able to calculate the radius of curvature, okay, now don't forget that here we are given the charge on alpha particle, okay, and we know that the mass of alpha particle, now in my previous video we have that the mass of alpha particle, okay, now this is the kinetic energy. We have the kinetic energy, okay, the kinetic energy to be 8.491 times 10 raised to the power of minus 13 joules. So that's the kinetic energy. Okay, now So to be able to calculate the radius of curvature, so we need to first find the value for the velocity of alpha particle. So to calculate the velocity of alpha particle, we know that kinetic energy is 1/2 multiplied by mass of alpha particle multiplied by velocity of alpha particle raised to the power of 2. All right, so which means that to be able to, now we know that mass of alpha particle is 6.67, okay, times 10 raised to the power of negative 27 kilogram. I already explained how to measure the mass of alpha particle in one of my videos. You know, we know that the mass 5 times 10 raised to the power of minus 27 kilogram. So because the atomic mass of alpha particle is 4, okay, so we multiply the mass of proton, we multiply by the atomic mass of alpha particle, and this is the value you will get. Okay, we're going to get this value. All right, so now we want to obtain the value of the velocity. So when we rearrange this equation, we're going to have 2ke, okay, now square root of 2ke divided by mass of alpha particle. So we have VE to be equals to the square root of 2 multiplied by, now the energy is 8.491 multiplied by 10 raised to the power of what? Minus 13. And we have the mass of alpha particle to be 6.67 times 10 raised to the power of what? Negative 27. So the units, remember, the unit is what? Meters per second. That's the unit of velocity. That's meters per second. So that now, when we multiply 2 when we multiply 2 by, that is 2 multiplied by 8.941, sorry, 491, 8.491, okay, that will be 16.982, okay, that will be 16.982. Then we divide it by 6.67, okay, now that will be 2.546. So we have the velocity of alpha particle to be the square root of 2.546. Now multiply by 10 raised to the power of, when we bring this guy here, it's going to be minus 13 plus 27. Okay, and the unit is what? Remember, is the meter per second. Now let's get the square root of 2.546. Now the square root of 2.546, that will be 1.596. So we have the velocity of alpha particle to be 1.596 times 10 raised to the power of, this is minus 13 plus 27. And when we raise, when we have 10 raised to the power of, that's minus 13 plus 27 will be 14. All right, so 10 raised to the power of 14. The square root of 10 raised to the power of 14 will be what? Will be 10 raised to the power of 7. And this is the velocity of alpha particle. This is the velocity of alpha particle. All right. Now, because we want to obtain the value for what? Radius of curvature. Now we know that because the charge, okay, the charge on alpha particle, okay, is moving along, is describing a circular track or a circular path along its track. Okay, so it means that the force making it describe the circular track, okay, or move in a circle, is what we have as the centripetal force. All right, then the moving charge, okay, would experience a magnetic force, or a magnetic, that's a magnetic force, yeah. So which means we are going to set, when we equate the centripetal force, when we equate it to, for what? I mean, when we equate centripetal force and the magnetic force, we are going to obtain the formula for R to be equals to momentum, all right, divided by QB, where B is the magnetic flux density or the magnetic field intensity. So this now becomes the mass of alpha particle, and this becomes the velocity of alpha particle. Okay, I already proved this in one of my videos. All right, so this is the radius of curvature. So from here we now have, what is the mass of alpha particle? 6.67. okay, times 10 raised to the power of what? Negative 27 kilogram. Then we multiply by velocity of alpha particle, which is 1.596 times 10 raised to the power of 7, all over. Now we have, what is the charge on alpha particle? So we are given the charge on alpha particle to be 3.2, okay, times 10 raised to the power of minus 19. Then multiply by the magnetic field intensity, which is what? 1, which is 1. So now let's get the value for 6.67, okay, times 1.596. Okay, that will be 10.645. So we have R equals to 10.645 multiplied by 10 raised to the power of minus 27 plus 7. That is when we combine the powers of 10. Okay, we can also bring this 19 minus 19 here, so that becomes plus 19. Then we have everything all over what? 3.2. We have everything that's over what? 3.2. So what is this value divided by 3.2? Divide by 3.2, that will be 3.3. That will be 3.33. Okay, so we're going to have, now the unit of radius is the meters. So from here we have the unit of radius is the meters. So from here we have 3.33. Okay, we have 3.33 multiplied by 10 raised to the power of, now we know that 19 plus 7, that will be 26. Yeah, that will be 26. So which means negative 27 plus 26. We have negative 27 plus 26. So that the radius, all right, the radius, that will be 3.33 times 10 raised to the power of minus 1. The unit, remember, is the meter. So when we multiply 3.33 by 10 raised to the power of minus 1, we're going to have the value of R to be 0.33 meters. The value of R is going to be what? 0.33 meters. So this is the value of the radius of curvature of the charge moving in a circular track. Remember, the noblest pleasure is the joy of understanding. Bye-bye.